Greetings to all and have a good day. My name is Anthony Blayong Anna George. My matrix number is B09-181-0068. So today I'm going to present my final year project 1, which is entitled as Asset Maintenance Strategy in Spare and Replacement for Hatchback in Oil and Gas Industry. So first and foremost, I would like to thank the panel, T.S. Hamzah bin Muhammad Dom, and also second panel, T.S. Sheikh Ismail Fairuz bin Sheikh Zakaria, for viewing my video. And not to forget, thank you to my supervisor, T.S. Dr. Ahmad Fuad bin Abdul Ghani, for assessing me throughout this PSM1. So without further ado, let's start our presentation. Okay, thus the content of this presentation consists of introduction, problem statement, objectives, scope of this project, literature review, methodology, summary, and also Gantt chart for semester 2 20/21. So we will start with the introduction of this presentation. Alright, first of all, I'm going to explain about the introduction. So, asset integrity is a term used to describe the practice of managing an asset, such as power plant, oil rig, refinery, etc., to ensure its ability to perform its function effectively and efficiently is maintained. The primary industry sector served by the asset integrity is such as upstream oil and gas. This is owing to the escalating worldwide demand for energy, which has resulted in the oil and gas sector increasing investment into this area to extend the operational service life of existing systems. And besides, uh, by implementing asset integrity to the hatchback system, such that the structural support of the hatchback is very crucial in implementing the asset integrity to the industry. Okay, so in this slide, I will explain about the problem statement. Even though it is knowledgeable efficient by using digital image correlation in finding stress analysis, it is a much more traditional ways. Besides that, it only focusing on a small scale testing, which is it is still much has to execute because the setup of the testing needs to be done as precise as it can be. The observed surface will have to be flat, plane and level, where the photographic lens optical axis must be set perpendicular to the measured plane, and the source of light must be very mild and steady. And also, the preparation of DIC is quite time consuming and budget because we need to prepare the testing materials uh, just in order to get a good and accurate result in doing stress analysis. So that is the problem statement that we will counter in this thesis. Thus, for our objective is that to design a tool used in analyzing stress in the hatchback system, which will replace a much more traditional ways to a conventional ways, so that we can counter such that uh, time consuming and also budget. So the second objective is to study the importance of stress analysis on its effect towards the behavior of the material and defects. So we will study more about the stress analysis or what and how it will impact a structural of the hatchback system. And the third one is to investigate the finite element analysis method on the parts and components of the hatchback. Next is our project scope or the area of study that we will cover in this thesis. So first is to study precisely way of using Autodesk Inventor by conducting a stress analysis and make it as a tool to identify stress. The second is constructing finite diagram modeling for hatchback parts and applying testing on the modeling based on the finite element analysis. And lastly is investigation is based on the oil and gas industry of hatchback system and will revolve around the application and similarities of digital image correlation method in finding the stress analysis. So in this slide, I will present about the literature review, and we're going through the literature review that I had. So first of all, is that the fundamental of stress analysis. So before I'm doing this, I need to study about the fundamental of stress on the introduction on what and how stress concept can be implemented and how it works. And the second one is the finite element analysis. So in the finite element analysis, there are uh, three ways or three studies that I covered, which is the principle of finite element analysis, the finite element equations, and also the finite element analysis nodes and elements. This is the basic things that needed to be known before doing the finite element modeling. So the finite element analysis are consisting of these three. And next one is the finite element modeling. So in the finite element modeling, there is a boundary condition, the loading, and also the meshing of the modeling. So this is important because in chapter 3 I going to uh, make a model. I will construct a model. So this study is uh, based on the previous studies that I had done. And next is the stress analysis criterion. So as you can see here, we have the von Mises stress, the first and third principal stress, displacement, and also the safety factor. This is the type of the stress analysis, such that the yielding of the solid body and the displacement of the knots, the safety factor uh, from the breaking point of the solid body. So in this stress analysis criterion, it is very important to study about this. And lastly is that the structure support modeling using FEA. So in this thesis, I chose two type of support that is usually used in the hatchback system or hatchback structure system. So which is the stand type support structure and also the bracket type support structure. This is because I studied this to make a comparison uh, on the both of this type of structure that is used in the hatchback. All right. So next on, we're going to move to methodology. So in this methodology, I will explain all the process that needed to be done to get the final result in the next semester. So first of all is that a finite element modeling. So first we're going to have to need a design. So here, as we can see, we have a hanger type support design and also a stand type support design. So after we having the design for this uh, modeling, then we're going to do an analytical setup of the model. So first, the model testing criteria. The settings and the objective for this analysis need to be determined in the first stage of the analysis. This will include the loading or the force that is going to be exerted on the modeling that is going to be constructed. So as you can see on the figure there, uh, first the design objective is a single point. This is the what we're going to do with our design. And the study type is a static analysis. So as we can see from the design, it is a static analysis because there are no rotating movement, or there are no movement, there are no dynamic analysis in this study. Alright, so next is that the meshing element and the convergence. Here, the size of the mesh is dependently related to the accuracy, and the value of mesh are an essential criteria for the meshing of the element. Thus, the reliability of the result achieved in finite element analysis is governed by the mesh size. So there is an example of a meshing in the modeling that I have constructed, and here I set up the meshing The average element size is that 0.0100, and the minimum element size as a fraction of average size is 0.200, and the grading factor is 1.500, and the maximum turn angle is only 60 degrees. So for the convergence, the maximum number of hash refinements is 0, and the stop criteria is a 10%, and the hash refinement threshold is 0.750. So this is very important so that the accuracy of this result will be given as much as possible. Alright, so we're still in the methodology section. So next is the material properties. So material properties is very important because uh, here we need to find like the mass of the support, the total mass and the area of it, the volume of the support, and also the center of gravity, the center of the support gravity. So this is very very crucial so that we can know the position of our so that we can do the loading layout later on, so we know the position of our layout, so the loading layout. Thus next is the operating conditions for uh, for the testing, the analysis. So first is that we need to set up our loading layout. So the loading is portrayed as the direct stress that is going to react onto the support. The load exerted are calculated as in Newton. So the load is typically or basically the stress that acting on the support. So here we can see that the magnitude of the load is 10 Newton. The vector x, y, and z is where the load is acting on, the direction of the load. So here we can see is vector y is negative 10 Newton. So that is the direction of the load going to uh, acting on the solid body. Next is that the selected faces. So the selected faces is also very important. So here it shows the direction or where the loading will act onto the support. And lastly is that the constraint. So a constraint can be defined as a property assigned to a column or the set of columns in the database table which prevent inconsistent data values to be stored into the certain column. So constraints are used to ensure the data integrity. This involves the reliability and accuracy of the data stored in the database. So here our constraint is a fixed type constraint. Thus, to summarize all the PSM1 is that this thesis is mainly about the usage of finite element analysis by using Autodesk Inventor finite M modeling to study the stress analysis that acting on hatchback support in comparison to the DIC or digital image correlation. Second is the literature review is to comment the idea on how the stress works based on the prior study that have been made, and the methodology is a way to execute the study by applying the steps and process for the analysis that is going to be done. So this is the Gantt chart for semester 2 20/21. So the total week is 14, and the project proposal is on week 1 and 2. Meeting with supervisor is along the project is executed, and the report writing for introduction the 3 weeks from week 3 to week 5, and starting with literature review from week 5 to week 13, and writing methodology report is from week 9 to week 13, and then references and conclusion from week 12 and 13, and for presentation PSM1 it's on week 14, the preparation, and also the submission of PSM1 report is on week 14. So that's it for me. Thank you.